In this lesson, we will focus on modeling the supporting structure of the sideboard. Looking at the reference image, we can see that at its base there is a support made up of two side panels and a horizontal crosspiece that ensures stability. Set the display mode to wireframe, the working mode to object mode, and switch to the front view by pressing 1 on the numeric keypad. Make sure the 3D cursor is positioned at the origin of the axis. If it isn't, press Shift-C to reposition it. To start, insert a cube. Then press Shift-A and click on Mesh Cube. Set the dimensions of the cube to the following values. X equals 2 centimeters, which is the thickness of the shoulder. Y equals 30 centimeters, the depth of the shoulder. Z equals 15 centimeters, the height of the structure. Having changed the dimensions of the cube, we can immediately notice that in the scale parameter of the transform window, the values are not all the same. From the previous lesson, we learned that these numbers should all be set to 1. So press Ctrl A and click on Scale to apply the scale and reset all the values to 1. Now we need to move the model into the correct position. But first, let's place the pivot point at its base. Let's make sure we've set snapping to vertex. Press Ctrl and the period key on your keyboard. The pivot point has changed its graphic appearance. This tells us that we can move it independently from the object it's attached to. Click on the Z-axis and while holding down the Ctrl key, snap to a vertex at the base. Alternatively, you can always press G, Z, and while holding down Ctrl, snap to a vertex at the base. Restore the pivot point by pressing Ctrl and the period key again. Now, to make the base of the model rest on the XY plane, simply set the Z value to 0 in the location parameter. Let's move the model to the left. Let's decide that the shoulder should be 20 centimeters from the left end of the sideboard. Click and hold the left mouse button on the X-axis. While also holding down the Ctrl key, we snap to the left vertex of the sideboard. In this case as well, we can press the G and X keys and with the Ctrl key held down, perform the snap. Press the G, X, and 20 keys to move the object 20 centimeters to the right, a distance that should allow us to almost exactly overlap the model with the same object shown in the reference image. The geometry we've set up provides a good starting point for detailing the modeling. Let's set a perspective view and zoom in on the model. Unfortunately, the reference image does not provide enough detail to precisely identify the shape of the support structure. However, we can assume that it is made from a square section tubular profile with a thickness of 2 centimeters on all sides except for the top part, which is 4 centimeters high. Let's switch the working mode to edit mode and make sure that Auto Merge Vertices is turned off. We'll see in a moment why this check is necessary. Let's add the following loop cuts. Press Ctrl-R to insert the first vertical loop cut, move it all the way to the left vertices, then press GY-2. Press Ctrl-R to insert the second vertical loop cut, move it all the way to the right vertices, and then press GY-2. Press Ctrl-R to insert the first horizontal loop cut, move it all the way to the bottom vertices, and immediately after press GZ2. Press Ctrl-R to insert the second horizontal loop cut, move it all the way up to the top vertices, then press GZ-4. Let's analyze what we've just done. After inserting the loop cuts, we first moved them against their respective vertices and then positioned them. If the Auto Merge Vertices option had been enabled, it wouldn't have been possible to reposition them because they would have been automatically merged with the vertices. Let's do a quick test and go back for a moment to the loop cut insertion phase. Let's enable the Auto Merge Vertices option. We insert the loop cuts and move them against the perimeter vertices. If we move the mouse to reposition them, the perimeter vertices systematically disappear. This happens because with the Auto Merge Vertices option enabled, overlapping vertices are snapped together and automatically deleted. Let's reinsert the loop cuts and return them to their correct position. We change the selection mode to face by pressing the 3 key on the keyboard or by clicking the corresponding icon at the top left of the 3D view. We select the two central faces. Right-click and choose Bridge Faces to create the required opening. Deselect everything by pressing the A key. With Ctrl+R, we insert another vertical loop cut in the upper section of the tubular profile and confirm its central position first by left-clicking and then right-clicking. Press Ctrl+B to perform a bevel, then drag the mouse to split the loop cut into two parts. Confirm with the left mouse button, setting an approximate distance. Open the window located at the bottom left of the 3D view and set width type to width, then set the corresponding field to 2 cm. Press the 3 key on the keyboard again to reactivate face selection mode. Select the innermost face, press E and extrude it for a more or less long stretch. The size doesn't matter. Now let's proceed to mirror what we've done so far to complete the support structure. Select all the geometry. Set the pivot point to the 3D cursor by pressing the period key and selecting the 3D cursor option. We perform this step because the mirroring will use the 3D cursor, which is positioned exactly at the center of the sideboard. Duplicate the geometry with Shift-D and confirm with Enter. Mirror the model along the X-axis with Ctrl MX. Then confirm with Enter. Let's examine this step in detail. With the key combination Ctrl+M, we activated the mirror command. By pressing X, we told Blender to mirror the geometry along the X-axis, and with Enter, we confirmed the operation. What we need to do now is join the two parts. Press the period key on the keyboard and click on the bounding box center option. To reset the pivot point center to its default value, select the two faces to be joined, then press SX0 to align them perfectly. With the A key, select all the geometry and merge any overlapping vertices by pressing the M key and choosing the by distance option. At the bottom, we can see that Blender notifies us that 4 overlapping vertices have been removed. Looking at the model's geometry, we notice that there is a face at the junction point of the two parts. This needs to be deleted so that the structure can be considered properly modeled. So, we select it, press the Delete key and click on the Face option. We also need to delete the edges, so we set the selection mode to Edges. While holding down the Alt key, click on an edge with the mouse. Press Delete and click on the Dissolve Edges option. As we've learned to do, once the modeling phase is complete, we check that the normals are properly oriented. Let's return to Object Mode and set the view to Solid. Enable normal checking from the Viewport Overlays panel or, using the shortcut we set up, press the Q key and activate face orientation. The part we mirrored appears red, which means the normals are oriented incorrectly. Switch back to Edit mode and press A to select all the geometry. Press Shift-N to correct the orientation of the normals, then switch back to Object Mode. Return to the standard view by disabling normal checking. Before wrapping up this lesson, it's a good idea to organize the outliner. With the structure selected, right-click on the media collection in the outliner and choose New. Rename the new collection to Media Base and move the support structure model into it. At this point, the modeling of the media is complete, and as always, save the file incrementally. In the next lesson, we will focus specifically on some details that will add more realism to the modeling, as well as on how to prepare the model for export, so that you can easily use it in other 3D scenes when needed.